So I will brief you about the idea behind the updates of the ITRF 2020. We plan to do regular yearly updates of the ITRF 2020. So I will talk about the motivation, and I will also talk about how we will do that, the update specifications, and show you some preliminary results for the first update. So the motivation for that, we have a number of arguments why we want to do that. First of all, errors in the ITRF station coordinates are more and more amplified as they are extrapolated to after the end of the ITRF input data. And the ITRF station subject to equipment change or earthquake or other events before the end of the ITRF input data, after the event of the ITRF input data, cannot be used anymore as reference frame stations. Most of the technique centers that who provide the contribution to the ITRF realization, they do regularly update their own realization of the ITRF. And the fourth motivation is this will increase the lifetime of the ITRF 2020 and may postpone the need for the next version of the ITRF. And in terms of scientific results, we see that the scale agreement between SLR and VLBI is now at the level of 1 millimeter, and that the ITRF origin and scale are now stabilized, as I will see in the next slide. And the seventh motivation is that this will simplify the life of the number of users with no datum change in their applications. So here I am listing the subset of transformation parameters from ITRF 2020 to past ITRF. So if we focus in the translation since the ITRF 2005, when we started to use time series for the ITRF combination, you see that the origin components, TX, TY, and TZ, and their rates, they are within 5 millimeter at epoch 2015.0, and the rate does not exceed 0.5 millimeter per year. And the same situation as for the scale, where we see stabilization of the scale at the level maximum 0.4 ppb, which means about 2.4 millimeter at the equator. And for sure, the ITRF 20, the old one, is now out of the picture, is discrepant by 3 centimeters. Now, in terms of specifications, we will use the same strategy for the analysis for the ITRF 2020, which means that we will accumulate the full 4-technique time series all together, where we add local ties and motion constraints. We preserve the frame and seasonal signal defining parameters in the origin, scale, and orientation. I will talk about this a little bit more in the next slide. The ITRF 2020 updates will be delivered using the same file format as ITRF 2020. And we realized that the technique centers of the IAG who are providing data to the ITRF, as we asked them to do, is they are using the same models and strategy as for their contribution to the ITRF 2020. So the analysis is still ongoing. And when we do the update, we have 42 degrees of freedom we have to fix. 14 parameters for the ITRF for the reference frame definition. Let me just put the pointer to, yeah. So, and then we have 14 parameters for the annual signals and 14 parameters for the semi-annual signals. And we actually do that using the minimum constraint approach, where you see the equations for the ITRF, the reference frame definition, and the seasonal signals here. And A is the design metrics of the partial derivatives. You have full equations in the ITRF 2020 open access article in Journal of Geodesy. Now, some preliminary results using the extended data. Here I am showing the origin component, Tx, Ty, Tz, for the SLR contribution using the intrinsic or internal constraint, where we used the ITRF 2020 input data in that equation of internal constraint. And if you this is the extended data, and if you include the extended data in that internal constraint, you can see very slight difference, especially in the X component. But this is a demonstration that the SLR origin and scale accuracy at epoch 2015 is below 1 millimeter, and the scale stability is at the level of 0.1 millimeter per year. Here I am showing the same parameters for the IGS GNSS with respect to ITRF 2020. Actually, the IGS GNSS time series that we are using are those reprocessed data aligned to the ITRF 2020. Despite that alignment done by the IGS, we see a very, very slight, some fraction of millimeter in the X component. But that will be readjusted when we finalize the ITRF 2020 combination. This is for Doris. The only thing that I want to tell you about is for the Y component, where we have an offset in the Y component, and the IDS is still investigating or looking for the reasons for that. There is a kind of nonlinear behavior in the Y component in general. And of course, the TZ component is just noisy because due to the mismodeling of the solar radiation pressure. Now, what about VLBI? We have the extended data, as you see here, after this vertical line. And here I am plotting the scale time series using the internal constraint, using the sessions in red here that were selected to contribute to the ITRF 2020 scale. And as you see, after the extension, the scale is starting to come back to normal. Now, if we include that portion of data after the extension in the scale definition for VLBI, we will introduce a bias in the scale of about 0.35 ppb at epoch 2015 and a scale drift by 0.03 ppb per year. Now, here I am showing the result of ITRF 2020 just to remind you what we had in the past with the full technique. So remember that we combined SLR dark weekly sessions with the red sessions, the weekly solution, sorry, for SLR, and the red dots of the VLBI sessions that we selected, about 2,700 sessions. And here you have in black the DORIS, and in green the original GNSS contribution to ITRF 2020. So the picture now with the update will look like this, where you can see the only difference is that the IGS GNSS time series of the scale are almost aligned to the zero line, which is the ITRF 2020. And again, we have the same behavior as in the ITRF 2020 for the ITRF 2020 update. We don't use this part here just to keep the frame parameters. And I forget to mention that we will have zero transformation parameters between the ITRF 2020 and the ITRF 2020 update, not only for the frame, but also for the annual and semi-annual signals. All these 42 parameters I mentioned before in my slide where I put the equations will be zero between the two solutions. Now, in conclusion, we don't see any major problem with the technique extended data. We can say that the stability of the SLR ILRS origin and scale with the extension is at the level of or better than 0.1 millimeter per year. The IVS VLBI scale comes back to normal after the extension starting at 2021. And by the way, we still need within the IVS to understand that drift that we showed in the ITRF 2020 result And now we are start to come to normal, but we need to stabilize the scale of the VLBI for future updates of the ITRF 2020. So the scale agreement, if we take that part of what we did for the ITRF 2020, is still at the level of 1 millimeter with no drift. And we expect the release date to be before the end of this year. Actually, it took us more time than expected for several reasons, but we still need about a month to finalize the solution. And probably by November, we will start to publish the result at the ITRF 2020 update website. So again, one important note for the users, there will be no change to the defining parameters of the frame and the seasonal signals in origin scale orientation between the ITRF 2020 and its first update. And the first update will have this name, ITRF 2020 U 2023. U for update, 2023 is the end of data, the end year of the data included in that update. And I will stop here, and I will be happy to answer questions if there are questions.
Updates. Are there questions to Zuheir? Yes?
Hello, Zuheir. This is Erik Opseth from Norwegian Mapping Authority.
Oh, Erik, good to see you virtually.
And thank you for a wonderful presentation. I have a question related to the motivation. Is it mainly scientific motivation, or are there any users that really are requesting a regular update of the reference frame? And what is...
No, actually it is motivated by the scientific results. We don't think that we will improve the agreement between SLR and VLBI in terms of the scale of what we use for the ITRF 2020, and we see a stability of the origin. That is the scientific reason. But there is also an application or user and motivation that the users don't want to change often the frame in terms of having a non-zero transformation parameter. So it is in both sides the motivation for the update. But of course, we will learn from that update. We already have some conclusions because we are toward the end of the computation, and we will see if a new version of the ITRF will be necessary in maybe in 2 or 3 years.
Okay, thank you.
Other questions? Yeah, Jose?
Thank you, Zuheir. It's Jose from IGN. I'm wondering that now with this way of doing things, what would trigger a whole new reanalysis?
That is a very good question. Thank you, Jose. Well, if it happens that we understand, for instance, I give just one example. If we understand with the help of IVS why we have that drift in the scale, and that we can reprocess all the data, and we get better agreement over the full time period between SLR and VLBI, this can be a motivation for a new release of a new ITRF. And the other motivation could be that also for SLR, if they find a way to stabilize, well, the origin is stable at the level of 5 millimeter or 0.5 millimeter per year. And in the future, if we have better results, we might need to have a new ITRF solution. The bottom line, you have to have an estimate of the accuracy of the ITRF better than 5 millimeter and 0.5 millimeter per year.